I guess I have a pretty hard task. It's Friday afternoon, it's some industrial IoT talk, and second day of the conference. Okay, so I'll do my best. A lot of the discussion around data has been already, how do we make use of it? How do we build applications? Because there's so much of that data, and it's really true. There is a lot of data. However, in an industry where we work and we focus on the real world, which is the ocean, the land, air, and space, the data is not that ubiquitous just yet. It is there, and it's coming, and it's growing, and the amount of sensors is spiking, but it is really hard to actually even get that data. So there's a lot of hurdles to overcome, and I'll talk about it and how we are using it and what we have done. A couple of words about myself. Background in robotics. I worked at ABB for 6 years. We did interesting things such as first fast charging network for electric cars nationwide in the world. That was in Estonia. I'm originally from Estonia. Been working a lot with unmanned devices, vehicles, production, and software. Most of these things have sensors on them, and most of this stuff is really hard to work with once you actually get all this data together. Then it all started from a small buoy, and we were struggling with how to organize this information together with some weather data from radars, with some data from satellites, and we discovered that the whole world is actually having the same problem. And we started a site called Marine Explorer, which is today the biggest free service online for public ocean data. We work with 33 organizations now around the world. I'll tell you about that later. And then from there on, we started to work with all kinds of different types of devices, from ships to buoys. We moved on weather stations, we moved to drones, we moved to satellites. And that resulted in us renaming the company to Planet OS, which is really a search engine or discovery engine for sensor data from the outset. And there are different trends that are happening, and I would like to kind of bring up with a couple of examples. One is that when did actually the weather forecasting start to kind of be inaccurate? You know, have you ever thought about that? And regardless of what you think of climate change, the data really doesn't help you to make any better decisions about the weather forecasting, specifically when you take into account the statistical observations about the weather, which have been a model that's old, maybe 10, 15, 20, 30 years, doesn't really give you the opportunity to judge. And when did it start to become kind of awesome? And the first people that actually start to utilize data to make forecasts were surfers. So there's a site called Surfline, and surfers wanted to know what are the conditions, wind swell conditions tomorrow morning at 9:30 on Steamer Lake in Santa Cruz. And none of the weather forecasting companies were able to do that, so they started to utilize ocean buoys and then extrapolate the data from those into like 6 hours ahead and so forth. And they have become infamous for predicting surfing spots pretty far out into the future with incredible accuracy based on their own experience and knowing the surf spots. It just became hyper-local and very focused. A second company that I would like to bring out that is doing a lot of interesting work based on data is Forecast.io. The company itself is called Dark Sky. They have an app that shows you the temperature and the precipitation around you if you're in an area which has radar coverage. And funnily enough, they tap into another data source which is provided by Weather Underground, which is owned by the Weather Channel. So there's a lot of play in the weather world, of course. And Weather Underground utilizes a lot of different interesting weather stations that they have, so to speak, authorized or said that this is a good device to measure with, and then when you buy that device, they will actually pay you a little bit of money when you put it in your backyard. So a lot of this Weather Underground data comes from crowdsourced sources, and people want to know, what is the weather like, so you contribute to that. This is an excellent model. Another question that we constantly are getting asked, why are oil spills happening? And I don't mean about greed or constructing the wrong way, but once you have the platform up and running, why did the operation really happen? This is an infamous photo, satellite image here of the Gulf of Mexico oil spill, and we tend to forget that the ocean is a really big place. This is the Gulf of Mexico. The name doesn't do it really justice, but operationally, to clean that up without knowing where to send your vessels, and mind you, the ocean is a four-dimensional space. It's a very dynamic environment. How do you actually do that without data fast? It's not really possible. So we have actually made a calculation. We could have saved $4 billion just because we could have helped them to speed up the collection by knowing where to send the vessels. And we have been selected into a partnership in Norway to build an oil spill response software, a new generation one, together with specialists alike. And we can do that on top of Plan OS easily in a 2 or 3 month period without having to build out the whole stack because we have built it. And so in general, it's come to like the biggest kind of industry collecting the most data is oil and gas. And they're literally, this is a quote actually from one of the technical executives at one oil company. It's like, we're swimming in sensors and drowning in data. And there are a couple of things that I've heard throughout these 2 days that I would like to kind of debunk. One was the idea there was a dream about creating like a semantic web. Although I understand what that means very well. In fact, be careful with that term with technical people, because the semantic web is dead for technical people. It's basically like Yahoo versus Google in the approach of indexing the web. And so you need to employ indexing and crawling technologies in order to be able to grasp all the information and read the metadata, and you cannot employ some rigid metadata entity models that all the data has to look like this in order to actually use it. But there's so much data, you have to know it even if it's not of a good quality, but you have to know it's there. And so that's what we've been actually doing. We've been employing these kinds of search methodologies. By knowing the devices and knowing the data, you can employ these things. If you don't know, then go back to tables. Sensor data is becoming too big to move. People really don't understand it. And so a couple of use cases here is oil spills happen very often because the data comes in on a physical level, but it doesn't come in on a software level. So we have met several people running plants who are looking at SCADA data or drone data, weather stations, and then satellite imagery, and still have oil leaks happen because there has been no correlatory software with machine learning involved that would predict or tell you immediately when an oil spill is happening or about to happen. And this is literally difficult, has been difficult to do because this data has been represented in silos and has never been integrated into one index. More numbers, HP predicts that by 2020, 40% of all data will have been generated by sensors and machines. And whereas we are talking about a lot of collection and automating and veni vidi vici, then I think the future is where we have automated these kinds of things, and we have actually a lever to automate even decision making, because we do not want to be involved in all the decisions. We're good in judgment. So as soon as we trust a judgment to a computer, means that this judgment process has been automated enough, or we know that thoroughly enough to actually do that. So we should leave the stuff that machines do best to machines, and the stuff we do best to ourselves. Very simply put, but not so simple to do. The big data space, I'm not going to spend too much time here, but the big data space was literally unknown 10 years ago, and today we're talking about that very much so, and it's only going to grow, and it's more about connected devices than it is about anything else, really. And an interesting use case is NOAA. For those who don't know, it's kind of like Ocean NASA, or National Oceanographic and Atmospheric Administration in the US, and they have 700 web services that they put out. They collect petabytes of data. They have 25,000 people, and this data is not really easy to access. Most people that deal with their data are frustrated because they have teams and teams to deal with this, but they have legacy software, legacy infrastructure, and there's no control over this data. NOAA hasn't put that out. So imagine if NOAA would decide one day, similarly like space, like NASA or SpaceX, hey, can you deliver this stuff to space with your rockets? If NOAA would say, hey, can you deliver this data to location X? So that's what we are trying to do, but this is a massive challenge. So not only us could do that. As I already mentioned, we have a site called Marine Explorer. This is an interesting play we have done. We have attracted a lot of attention in that domain, and we're moving more and more into the land space with that. And that really has sparked some interesting use cases. How do you understand the Sandy storm, and how do you get access to all the different atmospheric and oceanic data, and build new coastal ports and things like that. So it's really a means to mine and analyze and visualize data, and then we have enabled this with this tool. The use of data not only by data professionals, but also by executives and managers alike. So this is becoming a thing. So after this oil spill, by the way, now having these kinds of tools, there's mandatory also on an executive level in oil companies. So these need to be user-friendly. Another thing that we're doing is in Brazil, we're helping 5 big oil companies with the help of Bramante to make reports faster and real time, which in that case means 3 hours, but that's the way these things work offshore. It's really hard to get data out from out there. It is very heavy data. It's not just some time series data of your wearable. It is actually non-trivial in that sense. And so we have helped them to go from 24 hours to 3 hours. And instead of spreadsheets and emails, they're having a web interface where everybody can look at the same screen and take decisions in real time. A very nice example of data sharing among the industry. So really what we have built is a data platform focused on real-world sensor networks and working with the outdoors, let's say it this way, enabling to build applications on top of this platform in an easy way. So one of the taglines that we use in our company is that why would people want to build an entire operating system if they only need like a small interface on top? And normally you get like data professionals become pretty bad programmers and trying to create that. And so you don't need to build a Windows if you need to build an Excel. And so this map is an interesting map. This is a ping sent out on the 2nd of August last year. And these are devices on the internet. Imagine this map 10 years from now. It's going to be pretty massive. And some of these devices that are driving this change is robotic wave gliders. These have crossed the ocean without the use of power, by the way, they're wave-powered, wave-propelled. Marine acoustics is a space totally unknown for the normal consumer, but this generates a ton of data, and we have been working with, we hired Dr. Chris Clark out of Cornell University, who's a world-known bioacoustician, and we're working on some sound propagation software which would help to derive noise levels in the oceans and around sanctuaries and ports and things like that. Nanosatellites. This is a domain that is very interesting. So it's so far satellites are very exclusive. If I own a satellite, it's like I own an oil well, 150 years ago. It's literally like that. So Planet Labs and Spire and companies alike, Skybox are really, I would not say democratizing, but making data much cheaper and faster to get. And so in the next 10 years, I just read recently, in the next 10 years, it is estimated that we're going to see about 300 launches of nanosatellites. So there are only 300 more satellites in 10 years. That's a lot. There's actually now software in place to predict if any given satellites are on a collision course, and will tell either one to change its course without actually exposing its identity. Drones, if you want to invest money, invest in drones. There are a lot of FAA in US just enacted some legislation that will help commercial drones to grow. The biggest thing of them all, in my opinion, and I'm very passionate about food and nutrition and human health, I think it's really important to feed the world, and the way we do it today, it's really not going to fly. So you need to figure out how to do that, and I think we can play a small role in that, but I think it takes the whole humanity's effort in this. And there's one thing missing in all this, and which is data exchange, and data exchange which would allow you to give one interface to search for all your proprietary local or remote data, also your commercial data from vendors, and then public data from one location based on the data that you're allowed to see. So with that, we we really want to index the real world, and we really want to index your world, as in if you are our customer. That's it. Thanks.
Rainer, thank you so much. Really interesting stuff. Sense data will outgrow social data in 2 years.
Yeah.
Is that including video, or are you talking about different data points?
Actually, yeah, that's true, yeah.
Okay.
I mean, if you look at how much, I know video is big, and if you look at the internet curve, like YouTube, before and after YouTube, there's like a big curve up in terms of volumes. But if we look at data such as seismic data, if we look at satellite imagery, if we look at like just active sonar, and then drones, also video data, photos. This is beyond any data already today, but at the rate where things are growing, it's just we see like a new unmanned device on a weekly basis, and we monitor these things all the time.
Sea, land, air, space, nano satellites. There's an awful lot of movement around there at the moment as well. Really kind of democratizing space in a weird way. And you guys are an industrial IoT kind of platform. I'm interested in what you said right at the end, in particular, about the fact that a lot of people approach this stuff where they're trying to build up the whole stack, but they don't need to. Visualization, therefore, is what you enable to a certain extent.
Both.
And I'm interested in the part that visualization plays, is what I'm getting at, because with all these swaths of data that we're seeing and we're going to continue to grow, if it's all just ones and noughts, then it's data and it's not knowledge, it's not information, it's not something that we can act upon. So I'm interested in your thoughts in how we can make sense of that data from a kind of user interface, a kind of UX point of view.
Yes. So we work a lot with data, and we have 2 goals. One is to make that data machine readable, and then to make that data understandable for humans. Actually, we don't need to do that, the latter, but we have to do it because we feel that nobody has done it, and we need to show how it actually works. And we have recently hired the world's top data visualization engineer and data engineer, not a data artist, because it's really important to employ both parts, art and technology. And this person has actually an art degree and a PhD in information and visualization. You need to do it in a way that scales, and the visualization is the result of reading the information, not just one-time effort to create like an infographic or something beautiful, but it needs to be out there all the time. It needs to react to the user's needs. It doesn't need to be there when you don't need it, things like that, and it's very hard to do, actually.
No, good stuff. And we're going to be talking a lot more about design, user experience in the session after lunch, but I kind of wanted to bridge into that, seeing as that's where a huge touch point, and the visualizations on the screen were very interesting. Does anybody have any questions for Rainer on Planet OS? Yes, lady just there.
I hope it's not too lengthy, but I'm really curious about the point you brought up about agriculture and how you can contribute to those models. But I'm wondering if your idea is more to contribute to existing models or really changing the face of those models.
Do you mean models as in predictive models, or do you mean models? I mean
the way that agriculture is structured. So I guess I'm from the States, and their monoculture is really prevalent. And for me, I'm very interested in changing those models to be more environmentally sound.
Yeah,
and holistic.
There's this big fight, small farmers, big farmers, Monsanto and everybody else. There's no easy answer, but both parties, so to speak, small and big, are working on trying to get soil measurements, and then get like sun radiation and wind and rainfall, and then combine that with some kind of your own personal data that you have collected based on yields of the last years and so forth. And then run some kind of a model to predict, like, if I make this decision, how would my balance sheet look like? And if I, at the end of the year, and if I do this another decision, and this could result, I can use maybe with the right combination, I could spend less on this seed and no pesticide, and actually achieve more, and things like that. And I think that's where everybody's trying to figure out. However, I do think, and it would require a very different conference probably, but I'm a nutrition geek, and the way it's approached right now is still based on the same models, how people eat. But I do think that we would need to change it, and we're working with Dr. Patrick Bateson from Cambridge, on visualizing and showing the choices of humans, both in Europe and in US, based on the kind of the scarcity of food and water in, for example, Spain and California, very similar in that sense, and how people how to drive change in behavior of people, how they choose what to eat, how they eat, and you know, things like how they think about the human body and how to keep your energy level up. So that's something that's going to change the manufacturers, not vice versa, and that's because of our indifference. You know, companies like Monsanto and everybody has been able to go top down, but it's changing like everything else in the consumer. The food is going to be the same thing.
Terrific, thank you. One more question? Yes, at the back there. Microphone's on its way. Thank you.
Sorry, I was just wondering about open source and what is the role of it in your company?
So the question is, what is the open source?
Yeah. I was just wondering about open source and is there a role of it in your company?
Yeah. So we're doing two things. One is that marineexplorer.org is a free service, and when we expand data sets, it's still free, and everybody can access this. And so that's one of our contributions, which frankly costs a lot of money for a startup. And second is the ability to build applications on top. So we really are not in a position yet, but we would like to issue an SDK so that people can build their own applications. And then second, build visualization frameworks that people, and outsource that, open source that so that people can contribute to how to visualize better. And then coming back to the kind of, it relates to both overarching these things, is that at some point it would be very good. We talk about big data, but actually big data is a small data. And so it would be really good if people could actually start contributing to all this public data that is available. It's much harder to do for sensor data than it is for any other data because of the reliability of the data. Data quality is a huge issue. So there may be contributions in data quality, or maybe a model marketplace, or you know, there are all kinds of possibilities, but we haven't gone there yet.
And we certainly touched yesterday on sensor data, particularly around air quality and so forth, being incredibly unreliable, garbage in, garbage out and all that.
Yeah.